Good morning, everybody, and welcome back to Nextdoor NetAdmin. Some of my coworkers seem to be having some difficulty with VLANs lately. So let's talk about VLANs. I'm just going to jump right into it. First question you might have is, what is a VLAN? A VLAN is a virtual LAN, or a virtual local area network. You can think of it as the same kind of result as if you had several different switched networks, all in the same area. You could have, if you wanted to keep them completely separate, you could have them going through different sets of equipment so that the traffic never mixed. With a VLAN, you can do the same thing on the same equipment. So the way that this works is when you have a VLAN, it has a particular ID, say VLAN 6. VLAN 6's traffic will be kept separate through the network and only allowed to interact with other VLAN 6 traffic. And if a device like a router has multiple VLANs available on the same line, it will break it into multiple sub-interfaces so that VLAN 6 has its own address, and that's only going to interact with VLAN 6. All the other VLANs are kept completely separate. So that's the general idea of a VLAN. How is this actually implemented? The most common standard that you'll see for VLANs is called 802.1q. 802 is the IEEE standard for...
Okay, hold up. Hi, this is the Nextdoor NetAdmin coming to you from in editing, because what I'm about to say is completely wrong. Oh, the things you find out when you go back and do your actual research later. Yeah, well, 802 is the IEEE standard for local area networks, personal area networks, and the like. What I was about to say here was completely wrong. 802.1 specifically deals with other higher layer LAN protocols, which is what I'm about to talk about. 802.3 deals with Ethernet, and 802.11 deals with wireless. There's a lot of groups. We're not going to get into all of them. I am going to return you to your regularly scheduled, hopefully error-free broadcast.
So you can have some security protocols like 802.1x. The VLAN protocol is 802.1q. Because of this, network admins and other networking literature also tend to just refer to this as .1q. We leave the 802 part out. Everybody understands it's there, but it's just .1q. So in a .1q network, regular traffic without .1q being in play has a set format in the layer 2 Ethernet frame. When .1q is in play, you get an additional tag added. It's just 4 bytes, 32 bits. Of those 32 bits, 12 of them are set aside for the VLAN ID. I won't go into what all the others do right now because, quite honestly, that's more than we need for today. But these 12 bits allow you to specify a VLAN ID anywhere from 0 up until 4095. You can't actually use 0 or 4095. Those are reserved by the spec. So functionally speaking, your VLAN identifier can be anything from VLAN 1 to VLAN 4094. And you can use whatever numbers you want as a network admin, obviously provided it doesn't collide with what somebody else is trying to use. If you're working at an ISP or at another very, very large network, it's also possible under an extension to the standard to have Q in Q, where you have 2 VLAN tags, one right before the other, that allows you to network VLAN traffic over another network that is itself using VLANs. But again, that is much more complicated than we need to get into for the purposes of this discussion. So, When normal traffic is sent from a printer or another device that has no concept of VLANs, doesn't know that they're in use, and it doesn't have to know that they're in use, it just sends standard Ethernet frame. No VLAN tag whatsoever, no .1Q tag. When the switch receives that, the switch looks at its configuration and says, this is an access port, meaning it's only assigned to a single VLAN, and that VLAN is this number. And so it will take the traffic on that port, and if it needs to send it elsewhere in the network, it will add the VLAN tag so that it's tagged with the correct information and then sends it off. And the rest of the network can interpret that and deal with that how they need to. You can also have a trunk port. If you have a trunk port, this is designed to carry a lot of different VLANs, all the VLANs in fact. You can optionally restrict which VLANs a trunk will carry. You can say, this trunk port, I only want it to carry VLANs 10, 20, and 55. You can do that, and then that trunk will only carry VLANs 10, 20, and 55. Fine. It won't carry anything else. To the other VLANs on the network, it's as if that port doesn't even exist. The traffic has nowhere to go, unless there's another trunk that allows it to flow outbound, or there are other local ports. You can have a VLAN configured just on a single switch, and then the traffic will only stay on that switch and it won't go anywhere else if it's not permitted to. So that can be useful for some cases. But when you have a trunk, it's important to know that there is still an untagged VLAN. And this is called the native VLAN. It's very important that you understand that the native VLAN is set per port. It's not a global setting across the network. There is no global setting across equipment. It is set per port, and it is set per the admin. VLAN 1 tends to be the default VLAN. It's the one that's always there. If you set up new VLANs, VLAN 1 is just what all the equipment starts at. So a lot of networks use that as the default VLAN. You shouldn't use this as your default VLAN. If you have a lot of equipment already set up, yes, it can be a bit of a pain to move it to a new VLAN. Say, I'm going to take everything that didn't have a VLAN before, and I'm going to make it VLAN 5. Okay, now I need to set up a VLAN 5 on the router, and I need to configure the interface, and I can't configure the interface on the router for VLAN 5 with the same address as on VLAN 1. That causes problems. So then you have to remove the address from VLAN 1 and add it to VLAN 5, and you have to make sure that you can still reach all of your switches while you're doing this so that you can put it. It becomes a whole thing, and I understand, truly I do understand, that this is a lot of effort to have to go through. But you shouldn't use VLAN 1 for your regular traffic. You want to know why? The reason is VLAN 1 is the default VLAN. For a lot of systems, this can end up conflicting with other things that expect to be allowed VLAN 1. If you're using Fortinet gear, for example, with 40 link to link 40 gates to 40 switches to 40 APs to 40 analyzers to 40 sandboxes to 40 mails, all of the 40 gear that is in a 40 link, 40 EMS or whatever else it's got, all of it expects to be allowed VLAN 1 and only VLAN 1. That is it. If you have other traffic using the untagged VLAN, VLAN 1, that's too bad. You got to take all of it off because 40 link is going to take that over and you don't get a choice about that. So that's one reason. The other reason is for security, you never want the native VLAN on an interswitch trunk a trunk line between two switches, you never want that native VLAN to carry actual traffic. Why is this? Again, the native VLAN is set per port. That means if you have VLAN 5 on one end as the native VLAN, this is what's going to be untagged traffic. It's going to be sent without a tag because it's the default or native VLAN for that port. Maybe on your switch over here, you have a native VLAN of 10. So any untagged traffic it receives is going to be considered to be VLAN 10. This kind of VLAN jumping, where it leaves one switch on VLAN 5 and comes into the other switch on VLAN 10, is a security risk. It's a problem because you're breaking the guarantee that these VLANs are logically isolated and logically separate. And now you're mixing the traffic of two different VLANs. Not only is this a security violation, you're also increasing the size of your broadcast domain, the number of stations that have to be reachable anytime a single station needs to send out a broadcast at layer 2, which causes performance issues and other such fun things. But the security thing is the biggest one, pretty much. So for general reasons of security, you always want your native VLAN on trunks, on inter-switch trunks, to not only be a default for, and making it be the default is just good practice in case the admin forgets something. If the admin is guaranteed never to forget this, fine, you can set your native VLAN to 999 or something of that sort. But the native VLAN on all inter-switch trunks should be a VLAN that is not used for any customer traffic whatsoever, which means that all customer traffic, all regular network traffic, will have a VLAN tag guaranteed to make sure that the receiving switch always knows exactly what VLAN it belongs to with no ambiguity whatsoever. There are a couple of reasons why you might end up with a trunk link connected to an end station, such as a telephone. A lot of VoIP telephone handsets have the capability to accept a single network connection and then pass through a computer port to a computer that's also attached to the phone. How does this work? Well, typically you're going to have two VLANs. One is going to be for data traffic, the other is going to be for voice traffic, so that voice traffic is not interfered with or run into conflict with regular data traffic. So you set this up as a trunk line. The untagged VLAN, the native VLAN, is the data VLAN, and that gets passed through to the computer port. The phone itself listens to the network to be told what it should configure as the voice VLAN. And then any voice traffic that the phone part needs to send will get sent tagged for the voice network, while the computer doesn't need to know anything about the VLANs and it just passes through its data untagged to the regular switch port. And you can set up a switch port as a trunk in that case and configure it to announce the voice VLAN and do all the other fun stuff that you get to do in that case. But it's still important to know that your native VLAN is set per port. And this is why I'm emphasizing inter-switch trunk links versus end station trunk links. Because some end stations, like a phone, might require a native untagged VLAN that does carry customer traffic because it's intended to connect to a computer that is going to be on the data network. Only on inter-switch trunk links do you really want that native VLAN, the untagged VLAN, to be something that is essentially dead, doesn't carry any traffic, doesn't have any services, there's no router address on it, it's just a dead VLAN with nothing on it. So how does this work with wireless access points? Wireless access points can be considered another type of switch. It's just that they're handling traffic from multiple wireless clients instead of multiple wired clients. So if an access point is a switch, then you want to make sure that that native untagged VLAN carries no traffic. It's a security risk. It always has been, it always will be. And all of the data that comes from the AP that is actually supposed to go somewhere should be tagged. And a lot of APs will have configuration for this. If you set it up to handle a VLAN, by default, everything will start out as VLAN 1 because that's the default VLAN for everything. Fine. You can say, okay, my native VLAN is 1. My management VLAN, the one where I'm going to have an IP address that the AP can actually be managed, is a different number altogether. Then your management interface is tagged, even though the native VLAN is untagged. And your SSIDs, your wireless networks, should also be set to a particular VLAN identifier that is different from the native VLAN, so that when that identifier, when it accepts traffic on that SSID, it will set that identifier in the VLAN tag and send it off to the rest of the network. What happens if you have a manufacturer that is making assumptions? Some manufacturers make the assumption that, hey, my management interface is always going to be untagged. I don't need to set any VLAN tag on that. Now you've broken the assumption and the security practice that you never want to have actual traffic, meaningful traffic, on the untagged VLAN between two switches. Even though one of the switches is an AP, it's still functioning as a switch at layer 2. All right, now what? Okay, it's going to assume that the untagged VLAN is its native VLAN. It's going to assume that the untagged VLAN is the same one that its management interface should be on. Fine. And we know that the untagged VLAN is the same as the native VLAN. But again, this is set per port. On the switch end, you're going to need to make sure that you configure the native VLAN to be the VLAN you want this non-standard equipment to be using for its management interface. Okay. Now what about the SSIDs? Do we assume that VLAN 1 is going to be the untagged VLAN? We cannot assume that VLAN 1 is the untagged VLAN because the native VLAN, the untagged VLAN, is set per port. If you set up an SSID on VLAN 1 and just assume that that's the untagged one, so that's going to work out fine, it might, if that's actually VLAN 1. If it's not, then it won't work correctly. Let's say that my management interface is on VLAN 7, just because. Okay, and now I've got some substandard, non-standard equipment that doesn't let me configure a VLAN ID for the management interface. Okay, fine. Here's our scenario. I'm going to need to set my native VLAN on the switch end as VLAN 7 so that the management interface is on VLAN 7. Untagged, native VLAN, fine. That part is good. Let's say I've got a main network, a main wireless network SSID, and I want to put this on VLAN 7 because I want it to be untagged. I need to configure that as VLAN 7. Because if my native VLAN is VLAN 7, then anytime it accepts traffic on the wireless interface, it says, this is for VLAN 7, okay. Now I'm going to send it across this link. This link has a native VLAN of VLAN 7. So I'm going to send it untagged. Then when the switch receives it, the switch says, I'm receiving untagged traffic. I can see that my local configuration for this port says it's VLAN 7, and I can tag it appropriately as I send it through the rest of the network. Okay, cool. What happens if you say, VLAN 1 is the untagged network? Let's put VLAN 1 on this wireless SSID. Okay, now you've got traffic coming in there, and the AP says, oh, this is VLAN 1. My native VLAN here is VLAN 7. So if I've got traffic to send on VLAN 1, that means I need to tag it as VLAN 1 and send it into the network. When the switch receives it, it says, oh, this is tagged for VLAN 1. Okay, and now I can send it through the rest of the network, removing the tag if VLAN 1 is the native VLAN, or keeping the tag if the native VLAN is something else. Until it gets to the destination, it reaches an access port or a router or what have you, and it'll strip the VLAN tag and process the traffic at layer 3, because a VLAN tag is only at layer 2. So then it'll strip it off and it'll do whatever processing it needs to on that traffic. Okay. VLANs can be remarkably tricky for a lot of people. Honestly, I'm not 100% sure why, but then I am a network admin and my brain works in weird ways. Can't help it. But if you're struggling with VLANs, you're certainly not alone. Everybody else is commiserating with you. And those of us who do understand VLANs are, or darn well should be, happy enough to assist you and provide whatever guidance we can. It's kind of how we hope all learning works, really. Yeah. The biggest thing to remember is that your VLAN tag is not static. It has to be, you have to keep in mind the state of the frame as it passes through the network, because the tag might be added when it goes across a line that it's not the native VLAN. It might be taken away if it's going to be sent across a link where the native VLAN is the same one. And you can also have weird things happen if you send a packet with a tag for traffic that should be the untagged VLAN. Let's say I've got VLAN 5 on this switch right over here, and the native VLAN is supposed to be 10. Well, 5 is not 10, so it's going to be tagged for VLAN 5. Send it over. On this switch over here, VLAN 5 is the native VLAN, so it's expecting VLAN 5 to come in untagged. What happens here? Weird things can happen here. The switch might accept it, strip the tag off, and go, yeah, okay, this said it was VLAN 5, it's not supposed to be tagged, just get rid of the tag and keep processing it, send it somewhere else. Or it might treat it as a Q-in-Q packet and say, oh, well, I'm not supposed to be receiving traffic for VLAN 5 with a tag attached. So if it has a tag attached, this must be for VLAN 5 on a network which is already passing through on my VLAN 5. So that it's a tagged packet within an untagged packet. And weird things just go crazy from there. It's really important to make sure that you have a firm grip on what your native VLAN is, what it should be, and make sure that you keep the exceptions as limited as possible to prevent yourself from running into issues. There are protocols out there that try to make this easier. You can have an auto-negotiating VLAN trunk that instead of access or trunk will just try and auto-configure itself. In my experience, that causes more problems than it solves, because sometimes it's supposed to be one way and the switch says, oh, I've detected it's supposed to be the other, and things break. Try to stay away from the auto-configuring VLAN stuff as much as you can. It's just not worth it. There's also protocols like CDP, the Cisco Discovery Protocol, which functions at layer 2. Two Cisco switches running CDP will talk to each other, and they will exchange information, including what is my native VLAN. And if the native VLAN is configured differently on both ends, it will alert the administrator and say, there's a native VLAN mismatch here. It might even shut down the port to prevent traffic from flowing through an incorrectly configured VLAN trunk. And because CDP flows at layer 2, it doesn't have a VLAN of its own. It is its own layer 2 protocol. So the switches will continue to talk to each other and exchange this information, even if you're trying to say, oh, I only want this one VLAN to pass through. Okay, but the switches know if this is a trunk line, it might carry other VLANs at any point, depending on how the admin changes their mind. So it will warn you. It might cause traffic flow to shut down if you've done it wrong. So the best thing to do is make sure you've done it right. VLANs are a very tricky subject sometimes, but for today, that's probably enough on the subject for now. And if you have any questions, be sure to leave them down in the comments and I will answer them. Or if we have lots of questions, I might even do another video on it. We'll have to see. But for now, thank you very much for watching. I am your next door NetAdmin, and we'll see you next time.